So chapter 3 is all about solving systems of equations. Do you remember solving systems of equations in Algebra 1? You did. I can guarantee you did because it's a part of Algebra 1. Today we're probably going to start with the least favorite method because we're going to look at graphing to solve systems of equations. But later this week we will look at substitution and elimination. Okay, so I'm hoping maybe that rings a bell up there somewhere. But today we're going to start with graphing. So when we're trying to solve a system of equations, we're given two equations here. Thoughts on what I'm looking for when I'm trying to solve this system of equations? Do we know where we're going to find the answer or what it's going to look like? Or do we need to start working through the problem and then see what happens? I don't know. Did you have a thought, Lorna? Okay. Let's definitely start with y equals mx plus b in terms of how do we graph these, right? Okay, guys. I can't stress enough. Everyone's got to come in. Focus with me. I've got to have all 24 of you, well, 24 when you're all here, knowing how to graph y equals mx plus b. Okay? That's an Algebra 1 standard. It's an Algebra 2 standard. We've got to be able to do that. So, let's practice. Now, let's see. How do I want to do this? So, my recommendation is that in order to graph, is we go for y equals mx plus b form. So, I'm going to start with negative 3x plus 2y equals 8. Because the question becomes, can we graph it in the form it's in? Not really. Okay, we don't have a good graphing there. So, if we're going to go for the form y equals mx plus b, what's that mean? What do I have to do? Excuse me. What do we have to do to graph this, to get this in y equals mx plus b? Okay. Get y by itself. Is that the general gist here I'm getting? How do we get that y by itself? Okay. I heard something. I couldn't quite hear it. Okay. Okay, there we go. I like that better. You sort of say subtract 3x. I'm like, well, you can think of it subtracting as long as you subtract a negative 3x. But, as she said, subtracting negative 3x comes to adding 3x, right? So we are going to, since it's a negative 3x, we're going to add 3x. If I add 3x to one side, add 3x to the other side, right? Because what I do on one side, I'm doing on the other side. Negative 3x plus 3x, the whole point is they cancel out. 2y equals, what is 8 plus 3x? How would you write that? Okay, I heard both answers. 8 plus 3x or 3x plus 8. Yeah. Both are good. Okay? Yes, I agree. Not 11x. Why am I not adding these? Because you can't have, they don't both have x's, okay? So, I personally am going to write this as 3x plus 8. If you wrote it as 8 plus 3x, fine. Okay. Now how do I get y by itself? We're going to divide it by 2. Since it's 2 times y, we're going to divide by 2. If I divide that one by 2, divide every term in the problem by 2. Cam, put the iPad up. I can't tell if it's on or not, so. Oh, well. Definitely won't be on then, but now I don't have to question if you're watching it or if you're following along in the notes. Okay, 2's cancel, and we're left with y equals 3 halves x plus 8 divided by 2 is 4. Can I graph this? Yeah, I can graph this. So I'm just going to, it's not an answer, but I'm just kind of box it so we can remember to graph it. We can graph it. Okay. Think hard, guys. Because we're going to go ahead, let's go ahead and graph this, and then we'll work with the other one. Y equals 3/2 x plus 4. What do we start with? Okay, my b value is my y-intercept, right? So we're going to start right here. Where is a y-intercept of 4? Okay, so remember, I don't even know, can you see the tiny x, y, right? So a y-intercept is going to go up 4. So on the y-axis, 1, 2, 3, 4. Okay, now what? Okay, what's my phrase for slope? Yeah, we're going to rise over run 3/2. So from this point, up 3/2. Can you keep going? Yeah, although I keep going right there, I'm going off the paper. Can I go the other way?
Yes.
And that's advisable, isn't it? Okay, and I'm going to tell you for what we're doing today, it is incredibly advisable that the more dots, the better. Okay, so I'm going to go reverse and go down 3, left 2, down 3, left 2, down 3, left 2, down 3, left 2. Maybe I went a little dot crazy, but it will benefit us in the end. I promise. I have my reasons for going dot crazy in this lesson. Okay? The dots are going to make everything work out very nicely, but straight lines do matter in this lesson. Okay? If your line ends up curving, it could affect what happens in the end. So straight lines do matter. Now, again, if you have the dots, that's going to keep us straight. That's what matters there. Okay? Now, are we done? No. We graphed one equation. Now, we've got to graph the other one, right? So, do me a favor. If you're someone that struggles with y equals mx plus b form, it means a lot today, so work to stay ahead of me. Or work to try and answer my questions at least. Even if it's just answering them inside your head. Okay, what do I have to do to get this in y equals mx plus b form? Okay, we need this positive x term to move, so we're going to subtract x. If I subtract x on the left, we're subtracting x on the right. So now, 2y equals, okay, I would write it as negative x minus 8. But if you wrote negative 8 minus x, that's fine. As long as 8 and x are both negative, yes? Am I ready to graph? No, we got to get rid of that 2, don't we? Okay, so since it's 2 times y, we're dividing by 2 again. 2y divided by 2 is y. What is this negative x divided by 2? Okay. Yeah, there is an invisible what in front of that x? There's an invisible 1 there, isn't there? So if there's an invisible, this is negative 1x. The best way to think about this would be negative 1/2 x, is what I would write that as. Minus 8 divided by 2 is 4. Okay. Again, we managed to get this in y equals mx plus b form. What do I start with? Your b value, your y-intercept of negative 4. Where's a y-intercept of negative 4? Down 4 on the y-axis. And then what? I can agree with up 1 over 2 if you specify which over 2 we're going.
No, you go down 1 left.
Okay. So your options are, if you want to go up 1, you're going up 1, left 2. If you want to go down 1, you're going right 2. Because my slope is negative, one of your directions is negative, yes? One of them is negative, one of them is positive. So, if you are someone that you always put your negative on the top number, that's fine. That's what I tend to do. So that means I can go down 1, and then right 2 is positive 2. Down 1, right 2. I can do this about a bazillion times, right? Well, not a bazillion, I guess. That's a little exaggeration. And then reverse it, yes? Actually, reversing it is the more important part here on this one, if you know anything about where we're going. So I can also go up 1, which is positive 1. Left 2 is negative 2. Up 1, left 2. Up 1, left 2. Lots of dots makes this problem easy. Okay. Am I done? I've done all the hard work, but you haven't given me an answer yet, or we haven't stated an answer yet. I won't even say you haven't given me one because I haven't really asked for one. But you're not done until we state an answer. Thoughts on the solution to the system of equations here? Kylie? The point where they both cross, yes. Which is why, did you notice, did yours happen to have a point land on top of a point? Is there any guesswork about where these lines intersect? Where these lines cross? No. If you did this right, a point lands on top of a point, which means, I'm not guessing. I'm not saying, oh, it looks like it's about right there. I'm saying, my dots landed on top of each other. It is right there. Now, the hardest part of this answer, what is that ordered pair? So from the origin, I go 1, 2, 3, 4 left, and then I go down 2. So negative 4, negative 2. You have to state that answer to get full credit. And as we go through this chapter, especially in the first half of the chapter where we're solving a system of equations, and you'll notice how many equations did this system have? It had 2. This is our Algebra 1 review here. But your answer will always be an ordered pair, an x value and a y value every time. Okay? Now, if you get in a situation and your dots don't land on top of each other, not necessarily.
You did something.
Okay. If the lines cross and you don't have a dot specifically landing on top of another dot, my guess is there's a mistake somewhere, either in your solving of the equations or in the graphing. Okay. Now there are options where maybe the lines don't cross, but when would lines not cross? There's only one type of problem where the lines wouldn't cross. The lines are parallel, yes? That is your one time, if the lines are parallel, that you would get to say, no solution. Okay? The other situation you could have, and we're not going to see it in the examples, I can't remember if it pops up in homework or not. What if the lines land smack dab on top of each other? Yeah, so if the lines land smack dab on top of each other to where they're touching every point of the way, because they're the same line, how many solutions are we going to have? And that is infinitely many solutions, because they're always touching. So those are your special cases. Okay. Ready to try the next one? Okay, I'm going to grab the top equation and move it over here. X minus 2y equals 4. I'm off the screen there. Let me get on the screen. Okay. Can I graph it just as is? We wish. I don't know. You might be able to if you know the right tricks and steps, but what do we usually do then? Okay. Move the x to get y by itself, right? So if it's a positive x, we're going to subtract. If I subtract x on the left, subtract x on the right. As I carry this down, I'm going to carry down a negative 2y. 4 minus x or negative x plus 4 because it's a positive 4 there. Now am I ready to graph? No. Y is not by itself, so if it's negative 2 times y, divide by negative 2. Negative 2y divided by negative 2. The negative 2's cancel. Y equals, what is a negative divided by a negative? A positive. And then, can we agree with 1/2?
Yeah.
There's that invisible 1 up here. I don't know how many of you necessarily need to see the invisible 1, but it doesn't hurt, right? I'd rather put it in there than... What about 4 plus 4 divided by negative 2? 4 divided by 2 is 2. Positive divided by a negative is a negative. Okay? Can we graph it?
Yes.
Again, remember horizontal axis is x-axis, vertical axis is y-axis. Where do I put that first point? Okay, it's either up or down, right? I did have a few people I caught on the test on Friday where their y-intercept went on the x-axis. So always remember it's a y-intercept. It's got to go up or down. So we're going to go down 2 for negative 2. What's that phrase for slope?
Rise over.
Rise or run. So in this case, we're going to rise 1, run 2. Rise 1, run 2. Up 1, right 2. Up 1, right 2. And if you want to be a little dot crazy, you can reverse it. Down 1, left 2. Down 1, left 2. And do you see why I'm going a little dot crazy now?
Yes.
Because if I can get my dots to overlap, it's not about trying to draw a straight line and say, okay, where do the lines cross? Oh, wait, did my line get off a little bit? I don't have to worry about extending those lines and trying to figure out where the lines meet. I can just look at my dots. Okay. Oops. Next one. 3x plus y equals 5. Okay, to get y by itself, we're going to subtract the 3x. And then we're going to have, okay. Again, I'm keeping that x term first just to kind of prepare myself. Y equals negative 3x plus 5. And y-intercept of, how about positive 5? Right? Yes. Sorry. Want to make sure I didn't make a mistake here. Do you guys know what to do with your slope here?
It's over.
Yeah. Anytime you need to take a whole number and make it a fraction, you can put over 1, can't you? So then we're going to be going down 3, right 1. Down 3, right 1. Down 3, right 1. What do you think? Can I stop being dot crazy a little bit here? Mm-hmm. Yeah, once you find that intersection point, you can stop with your dots, can't you? Or you can keep going, you know. And again, unless your lines are parallel, they're always going to intersect somewhere. You just have to keep going out far enough till they intersect. Okay. Do you have an answer for this one? Okay. If you follow where they cross, they go right 2, down 1, which is the ordered pair, 2, comma, negative 1. Okay. I have a note to myself before we move out of the graphing section here. I have a note to myself to review our horizontal and vertical lines. You guys remember how to graph when you get a horizontal or vertical line thrown at you? So for instance, if you're given an equation y equals 2, what does y equals 2 do? It cuts through which axis? The y-axis at 2, right? Because it says y equals 2, it has to touch the y-axis at 2. Which one's the y-axis? The vertical one. And so the easiest thing to say here, we're going to go up 2, we're going to cross through the y-axis at 2. So that is a horizontal line when it's y equals a number. You can't see that I wrote horizontal there, but I promise I did. Okay? So anytime it's y equals a number, if you want to just memorize that as is, you can. Anytime it's y equals a number, it's a horizontal line. So what does that mean if I give you the equation x equals 3? It's going to be a vertical line, right? And the easiest way to think is it's x equals 3. It has to touch the x-axis at 3. It has to cross through the x-axis at 3. Which one's my x-axis? The horizontal one. So because it's crossing through the horizontal axis at 3, it's going to be a vertical line. Okay, so x equals a number is always a vertical line. We've already reviewed that once this year, haven't we?
Yes.
Okay, but I'm going to keep reviewing it because for some reason, they drop out a variable and it becomes the most confusing thing ever to graph. So, I'm trying to give you tips on ways to remember it. Okay, questions here? We're all set for graphing? Okay, so in my mind, the main point of this lesson is what we've just done. Solving systems of equations by graphing. So looking on the graph where they intersect. Now, we've got a problem here. We're going to talk about how we could use a table to solve it, which is what sometimes we do when we just want to use, some logic here. So let's look at this one. The growth rate of a Greenland shark is 7,500 centimeters per year, and its birth length is 37 centimeters. The growth rate of a spiny dogfish shark is of 1.5 centimeters per year, and its birth length is 22 centimeters. If the growth rates remain the same, at what age would a spiny dogfish and a Greenland shark be the same length? Now, again, I'm just going to look at how we can set up a table to do this. With that in mind, though, let's talk about how are we going to find the length of a Greenland shark? Okay, I picked Greenland to start with. Lorna? Okay, and what's going to be going on in that equation if we set up an equation? Okay, she says y equals 0.75x plus 37. Now, if you were sitting here thinking, I didn't want to think equations, Okay? Then put it in words. What do you already know about a Greenland shark? It starts at a length of what? 37. And then what are you doing? You're adding on 0.75 each year. So the first year you add on 0.75. The second year you add on 0.75 again, or in other words, 0.75 times 2. Then the third you add on 0.75 times 3, right? So do you see how we can think equation here? That way, you know, for instance, when you look at the second part and it says, oh, what about when it's 25 years old? You know, we kind of have an idea there. So, if we do that, what was X representing? Okay, because it says at what age. And if we're trying to find at what age, we're going to use X to be the age or the years. What does my total equation represent in the end? You're trying to find what did it, you know, that total centimeters, or in other words, the length. Now, and again, I'm not saying you have to think about this as an equation, but even if you don't think about it as an equation, you really kind of are somehow. You're just not acknowledging it that. So, if we think about this as, and even just forget the y and just say, okay, it was 37 plus 0.75x. I just realized I did that backwards from what Lorna said, but it's the same, right? If you'd rather write 0.75x plus 37, that's fine. Okay. Thoughts on the spiny dogfish? Okay. So yeah, what's it starting at? It's starting at a length of 22, and you're adding on what? 1.5 per year. So right. So 1.5. How many years? I'm gonna say X. 22 plus 1.5x. And as I said, sorry, I guess my Greenland and spiny dogfish are cut off. Hopefully you can use context clues and figure it out, right? We can use those ideas. Now, yes, we could graph this. Yes, we could use like substitution elimination, which we're reviewing later this week. But they're asking us for a table. So I'm going to set up a table here. And bless you. In my first column, I'm going to have my X value, my input, which is what's our input? The age, right? Because our age is what we would call the independent variable. It's our input, it's the variable, you know, we can't control the age of the shark, can we? Okay, not that we can control anything about the shark, but, you know, the age is the independent variable, it just does its own. Now, we're going to have two columns here. One column is going to represent the Greenland shark. And of course, that is the length of the Greenland shark. And the other column is going to be spiny dogfish. Okay, we said for the Greenland, we were basically going to be doing y equals 37 plus 0.75x. And for the dogfish, we said we were going to be doing what? 22 plus 1.5x. And again, it's not that you have to write those in there, but I'm just kind of writing in what we're going to be doing. Okay. Thoughts on what we should do here? Okay, do we want to start all the way at 0? No. Okay. I mean, here's the thought. Are we going to have to find every age up until they are the same? Not really. Okay, and by the way, let's review. What was the question? At what age would they be the Same length. Well, if one starts off at 37, the other starts off at 22, are they going to be the same length at 0? No, because they're at 37, 22. Are they going to be the same length at 1? No, because you will have added just a little bit to each. They won't have had a chance to catch up with each other. Okay, so should we start at like 1 or 2? Okay. 5, I would even, well, I guess I know where this problem goes. Can I push you guys to 10? Just, I know that we're going to have to do a little bit of work here, so. But here's the deal. Is 5 wrong to start at? No. Okay. And you could start at 1 and, work your way up from there, but if I start at 10, and keep in mind, 10 is what? It's a guess. It's, you guys, some of you said 1, 2, and then when I said, let's push a little bit, I heard 5, which was much better. Now, what do I do with this 10? Yeah, plug it in for x. Basically, find the length of the Greenland shark. So 37 plus 0.75 times 10. Well, what?
75 plus 10.
Not 75. 7.5 plus 37 is going to be what? 44.5. So at 10 years of age, we know the Greenland shark is 44.5. Okay? Check the spiny dogfish. Plug in 10 again. So 1.5 times 10, 15 plus 22. How about 37? I know, you made me second guess myself. I was like, oh, well, I thought it was 37. Okay, what do we know? They're not the same yet, are they? Okay. So definitely go higher. Do we want to make our next number like 11? Okay. 12. I'm going to go 15. Okay. And here's the deal. I picked 15. I heard a lot of different numbers, 15 amongst them. Are any of you wrong for what you're picking? No. It's a personal, and some of you are out there saying, oh, just go for the final answer, Mrs. Sargent. But I'm not doing that yet.
Not yet. So it's definitely not 15.
I know, I shouldn't have said that there. Dang it. Okay. 0.75 times 15, and then plus 37. What is it? 48.25, she says? Okay, that's good, because I don't have that one written down, I'm realizing. Okay. Check out the spiny dogfish. 22 plus 1.5 times 15. What was it? 44.5?
I found it.
Well, are we there yet?
No.
No. Are we closer?
I say we do 20 next.
First of all, answer my question. Are we closer?
Yes.
And here's the deal. How do we know we haven't bypassed it by chance?
Because the dog hasn't passed.
Exactly. Okay, right now the spiny dogfish is still shorter than the Greenland. Okay, it was shorter at birth, and it's still shorter. Now we're getting closer, okay, because the distances aren't nearly as far apart. So we're getting closer. And so this is where you take another guess, right?
Let's do 20. 20. Yeah.
Okay, so if we do 20, 0.75 times 20 plus 37.
52.
52. Okay, 22 plus 1.5 times 20.
52.
Just like I said. I have to write it down. Just like I said.
Okay, now, is it always going to happen to work out a nice, neat whole number like, well, I shouldn't say, a nice, neat round number like 20?
Absolutely.
No, but, it did in this case. And this is where you adjust your guesses and, obviously the calculator is helping you along. So, at what age would they be the same length?
20.
At 20 years.
So they even live that long?
Yeah, sure.
I say sharks.
I'm going with yes based on the problem.
I don't know about these sharks, but they're nice to live like 50.
Okay, On the next one, it's how long will each shark be when it's 25 years old? What do?
You just put 25 in.
I don't know this.
You put 25 in, right? Answers later? No, I saw it go out of the corner of my eye. And you will notice, well, you won't notice anything because you can't.
The green one has been surpassed.
Yeah, that's my point once you get my screen back up, is that if you had randomly guessed them, notice Spiny Dogfish has passed Greenland. And so at that point, we know that we've bypassed the point where they are the same. Okay, now, let's see. On the back side, and where did time go? I don't, yeah. Blech.
I feel like it was like 11.
I know. Last time I looked, we still had 23 minutes left in class. So, I'm trying to think how much this is in homework, or if I just want to skip this.
Well, I assume she's.
Do whatever you think is best.
Okay. Well, it is. Okay, guys. Try and come up with a game plan on the fly here. Do the homework. If you run into questions about independent, dependent, inconsistent, consistent, which I can't remember if you do or not, you're going to obviously have to skip those at this point. Okay? I'm going to decide when I double check. I want to double check my standards in a couple of things. I might end up skipping this part of the lesson. If I skip this part of the lesson, what's that mean is due tomorrow? Homework is due tomorrow, which is why I'm saying do any homework. Now, obviously, as I said, if it asks a question about inconsistent and all that, skip it, which honestly I'll have to get in there real quick before anyone starts the homework. And because if I want to take them out, I'll have to take them out right away before you guys start it. Okay? So, do the homework. If you run into something you don't know how to do, we'll talk tomorrow, about inconsistent and all that. Homework is what?
3.1 in Math Excel.
Lesson 3.1 in Math Excel. And I'm getting the graphing out of the way in the beginning of this chapter. We're going to graph today, we're going to graph tomorrow, and then we'll be over graphing. Okay? Then we'll get to talk about substitution and elimination. Okay?